Hey, good afternoon, everyone. Thank you all for joining us today for our weekly webinar series. Today's topic is professional track training. My name is Jessica Petrohoy, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about professional track training is Sonny Hunt. Sonny is the Director of Operations for the Adtell Group and brings with him over 30 years in the telecommunications industry. Sonny will be discussing the pathway to advancing your fiber optic skills through hands-on training, field experience, and certification. When Sonny is finished, we'll take questions from the GoToWebinar question box at the bottom of your screen for a question and answer session. So anytime throughout the presentation you have a question, go ahead and put it in the question box and we'll get to it at the end. And remember, our webinars are always posted at fiberoptic.com/webinar. Thank you again for joining us today, and at this time I turn the presentation over to Sonny.
Good afternoon, and thank you, Jess. I'd like to thank you for joining us today to learn more about the professional track training for fiber optics that's offered here at fiberoptic.com. Again, as Jess mentioned, if you have any questions, please hold them until the end of the presentation. You'll be able to type those questions in, and I will respond to each one this afternoon. Nearly every year, fiberoptic.com trains over 1,000 technicians in the fiber industry. We're seeing this really grow not only nationally but internationally as well. The infrastructure globally is growing exponentially, and the need for fiber is increased tenfold over the last 10 years. As we're talking to more and more people and technicians, the question that comes up more often than not is, what is a professional fiber optic technician and how do I become one? With the boom of the internet in the early 1990s and with the amount of fiber that's been deployed since then, you would think that you can go to any vocational school, a community college or university and enroll in a fiber optic program. As you look at these institutions, what you'll find is that there are individual fiber optic courses, most of which are theory-based. There are only a few schools that have the equipment, and none of them really provide the skills necessary to start at an apprenticeship level to allow you to become a professional fiber optic technician. So I think the thing there that's really unique to what we do at fiberoptic.com is our training does certainly provide the theory because that is important, but we also have hands-on labs that all of our students get a chance to work with the equipment, from the basic tools to power meters, light sources, so that when you leave that class, you're going to have real-world lab experience when you're in the field of things that you've actually done in class to give you that comfort level that you are a seasoned professional and you've seen that before, you know how to deal with it. So this webinar really is going to focus on three main topics. Who is a professional fiber optic technician? How do I become a professional fiber optic technician? And what are the requirements to become a fiber technician? Before I jump in and answer those questions, I want to spend just a little bit of time talking about the fiber industry in general. I really think it's important to understand where we are today and where we're going in the future. I also think it's important to understand why we have so many people today that are interested in becoming fiber optic professionals. I know recently you may have heard that Verizon was on strike for several months. They were outsourcing a lot of work looking for technicians that could easily step in during the strike and take over. So we're seeing just a lot of opportunities from all different areas, regardless of whether it's higher ed, whether it's cable TV, just about financial. Everybody is doing fiber optics. When I meet new people, they often ask me what I do for a living, and when I tell them I work in the fiber industry, I typically get a blank stare, or they're really not sure what it means to be working with fiber. Although the word fiber is more common today than it's ever been before, most people really don't understand that fiber is what allows them to enjoy this data communication that everybody has become used to today, either on their iPhone or their smart device their television at home, at work. It just everywhere you go, that communication is on a fiber network and a fiber backbone. They certainly don't understand that fiber enables light pulses to travel down a strand of glass that's about the size of a single human hair. And they may not even know that every day they're touching something, watching something, or talking on something that's brought to them via a fiber optic communication. My introduction to fiber optics started with the growth of the internet in the early 1990s. And it's really amazing to me when I think back on that. I started an internet company in 1993. It was called Fastnet. And we were the 8th internet provider in the country at that point in time. So from just 1993 to where we are now over the last 20 years, the growth of the internet, the growth of telecommunications, and certainly the growth of fiber is just astounding of where we are. So not everyone understands why the fiber is there and why it's necessary, but it does affect just about everyone. So I've compiled some interesting examples of how fiber optic networks are touching our lives on a daily basis. Today, nearly 50% of all couples that are married met online. That's pretty amazing when you think about over the years in past that you used to go out to the bars or you met someone at work. Certainly not the case anymore. There are currently 1.4 billion active users on Facebook. In perspective, if Facebook were a country, it would be the most populated country, passing China, which has a population of 1.3 billion. So more people using this online application than there are in any of the most populated areas of the world. There are over 3.5 billion searches on Google every day. Every minute, Twitter users tweet nearly 300,000 times. Instagram users post nearly 220,000 new photos. YouTube users upload 72 hours of new video content. Apple users download nearly 50,000 apps. Email sends over 200 million messages, and Amazon generates over $80,000 in online sales every minute. Again, the purpose of this slide is we don't always think about how all of these things come and how they happen. And all of these are based upon fiber optic networks that are built, technicians that are out there building, maintaining, and repairing these networks. There are more mobile devices in the world today than there are people. So think about that. That means everybody has more than one mobile device with them at any given point in time. Shopping. I know all of us are probably doing a lot of online shopping. In 2015, Black Friday, the day after Thanksgiving, shoppers spent $2.7 billion in brick and mortar type stores. On Cyber Monday, 2 days later, shoppers spent nearly a little over $3 billion. 800 million of that originated from mobile devices. Again, people out there using these networks, doing things requiring a fiber network to support them. The average home in the United States has 3 televisions, while each home only averages 2.5 people per home. So again, the way we talked about with mobile devices, more televisions than we actually have people. The thing here is there's been this, in the past 4 or 5 years, this big migration to HD TV. Each HD channel requires about 7 meg of data transfer. On top of that, more homes are asking for video on demand. We're downloading movies. We want better picture quality. All of these things, all of these demands that we're asking at our home are only possible by building fiber networks to our homes. So again, drawing back on this whole theme of everything that we want to do is based on a fiber network. So I think all of us will agree that today fiber plays an important role in our daily communications, even if we don't always recognize that fiber is behind the majority of our daily activities. But if we're already doing all of these great things right now, what does the future hold? Well, really what we're talking about here is still data, typically referred to as broadband communications. No matter where you are, if you're at home, if you're at work, if you're shopping, at a sporting event, at a restaurant, there's a need for broadband data transmissions. And it's this need that's driving businesses to move away from traditional copper technologies that have been installed for hundreds of years to fiber optic networks. This need is creating the demand that we have today for fiber optic technicians. So why are fiber optic networks a requirement for broadband technology? Well, the simple answer is speed. We could do some of the things that we're talking about here that I mentioned before through a copper network, but it simply wouldn't be as fast. Even in your neighborhood now, if you don't have fiber to your home, but let's say that you're in a neighborhood where you have fiber part of the way and then you have copper that goes from the distribution point to your home. Well, what you may notice is there's busy times of the day when everybody is at home and everybody is online doing things. During those times of the day, there's only a certain amount of bandwidth that can be pushed down those copper lines. And you'll probably notice at your home between 5 and 10 o'clock at night, it's much, much slower as far as your internet is concerned. If you have HD TV, sometimes you'll see a lot of pixelation. So the goal there is to replace those old copper networks with fiber optic networks. So we want our data and we want it now. It's very frustrating when you get used to that speed, when you don't have it anymore, then you're calling up your cable company, you're calling up everybody saying, there's a problem with my service, I want it to be faster. A single strand of fiber can transport 10 trillion bits of information per second. Or to look at it another way, that's like downloading 1,900 CDs or 150 million phone calls every second. That's what we're talking about with speed. That's what we're talking about with fiber compared to a copper network. Fiber is robust enough to handle the current and the future data requirement needs without the need for data compression. I think compression, if you're not familiar with that, still a lot of the copper networks are doing that. It's where they compress the packets, and again, they're trying to send more information down that copper pipe. And a lot of times what happens when you're doing that, you'll start getting pixelation. If you're on a VoIP call, you'll start getting things where you're missing words out of the conversation. So we're just to the point where fiber networks are going to displace copper networks. You'll often see articles that show the United States is lagging behind many of the other countries in the world in regards to the amount of fiber communications that have been deployed. The reason for this is fairly simple. In the United States, our infrastructure for the last 100 years was built based on copper networks. In many countries, there was no prior communication systems, so they're just getting started here within the last 10 years. So they're not building copper networks, they're starting with fiber networks. So for them, it's deploying new networks that are based out of fiber. Here in the United States, while we have deployed a lot of fiber in the last 15 years, again, we've got 100 years worth of old copper networks that ultimately are all going to have to be displaced with fiber. If you're in the industry of providing fiber and communications, this is the highlight point of this because it's going to take a long time for us to displace those networks. So obviously there's going to be a lot of work for all of us to come for years to come. In the United States, if you happen to be lucky enough to live in a Google city, or if Verizon has been to your neighborhood and installed Fios, or if Comcast has installed Xfinity, you're probably pretty happy with the speed of communications that you're getting on all of your devices in your neighborhood. If you don't live into one of these places, you probably have limited choices of who your providers are. The infrastructure is probably still based on copper wiring that reached its capacity a long time ago. And it's these underserved markets that greatly outnumber the current built regions in the United States. So there's a lot of opportunity moving forward, either with these companies, doing work with Google, with Verizon, with Comcast, with Time Warner, with all of these other communications providers, or for entrepreneurs that are looking to establish their own business, to either work with these companies or develop networks on their own. So where are the opportunities coming from for these professional fiber optic technicians? Well, certainly, as I just mentioned, one of the areas of growth is Google. This map here represents where Google is hoping to build out their Google City and their Google networks. As of today, Google is present in only 3 of these cities. There is probably 10 more that are currently being built out, primarily along the eastern seaboard, but certainly across the country as well. I think Google's interest here is twofold. One is they certainly want to bridge the gap to bring faster communications to everyone. The second thing is, if it's Google's fiber, then Google can control the content. And the old thing used to be in telecommunications, he who controlled the last mile controlled the customer. And it's really, that's still true today, but it's really who controls the content that's on that last mile. I believe that we are in a shift currently where cable TV, as we have known it for a long period of time since the early 50s, is about to change. There is a demand from the user base to have on-demand programming. People no longer want to wait till 10 o'clock to see a particular program, or that they want to, if they can't make it on Tuesday night, they want to watch on Wednesday night. The internet and fiber communications gives us the ability to start to schedule more of these. And I do believe that as we move forward, you will start to see more a la carte programming, where if you don't want to, if you want to watch a CBS program, you'll go to Netflix or you'll go to the CBS site and you'll be able to watch whatever that program is. But certainly Google is certainly one of the ones that everybody kind of knows about, and we all kind of look forward to as advancing this fiber technology. And obviously from this description here, we think that there's a huge growth potential as all these cities are built out, certainly in the building stage, needing technicians, testing, and then after those networks are up, adding new customers, moves, adds, and changes, and then certainly for doing repairs. Comcast is also a company you probably have heard a lot about. Comcast plans to offer internet speeds of up to 2 gig per second to the majority of its nearly 22 million subscribers by the end of this year. There are also over 200 million homes and businesses that are in the United States that Comcast has a footprint to. All of those are going to need to be built out too as well. Telemedicine. This one is something that's fairly new. You may have heard more about this, but if you have a fiber network at your home, it is now possible that you can have what's called a video visit from your doctor. Basically, from your device at home, you can be online with the doctor. He can get real-time stats about the patient, heart rate, pulse, have that conversation back and forth. How are you feeling? What's going on? And almost doing an exam, for lack of a better word, while you still are at home. So the doctor can give you instructions and help diagnose quicker what may be the issue that you're having. Stadiums and venues. When hundreds of thousands of people gather for an event, you can imagine that the local communications is crippled by that volume of data that comes from all of these new people coming all at once into an area that isn't there on a regular basis, particularly as it relates to mobile devices. A distributed antenna system, or DAS, is a way that we are starting to deal with these isolated spots of poor coverage that are either inside a large building, inside a stadium venue, a racetrack venue, football stadiums, basically any type of arena. What these DAS systems are they're relatively small antennas that are placed throughout the building or throughout the arena, and they serve as repeaters. So from these antennas, the local cell phone, whatever the device is, makes a call from that device to these local DAS antennas. These DAS antennas have fiber backhaul that takes that wireless call, that wireless data request that you've just made, and fulfills that back through some other network to get that information from instead of celestial through a network that's actually been deployed by fiber. Another thing we're starting to see a development in is what we call small cell. To me, the major difference between DAS and small cell can be described is DAS is perfect to extend coverage. Small cell is designed for more of increasing capacity. So with mobile data traffic expected to double annually, small cell-based stations are set to play a really important role in expanding the capacity of current wireless networks. Mobile operators are realizing that to meet the demands for this data, video applications that are being accessed by smartphones and other devices, there's a real need to go small. These small cells provide better coverage, have lower latency, and like the DAS antenna, utilize fiber to haul the data back to the central office. So again, using that fast wireless connectivity locally from your home to a small cell, and then from that cell, you're riding a fiber network back. So obviously one of the reasons why the deployment of fiber is taking so long is there is a substantial cost in building out all of these neighborhoods. Adding a combination of small cell and fiber will help move that technology along much faster than just deploying fiber networks alone. So why does fiber have so many people excited? Well, number one, there's lots of employment opportunities for installers, for technicians, for engineers, for mapping and asset management of fiber networks. There's increased revenues for current businesses. More businesses can now sell online. They can better promote their business. They can increase the different types of services that they're offering. And then lastly, for entrepreneurs, it gives people, without having to invest millions and millions of dollars into ideas, the ability to start their own business, to start to deliver content across these networks. So back to those three questions that I posed at the beginning of the webinar. Who is a professional fiber optic technician? How do I become a professional fiber technician? And what are the requirements? So let's take a look at what I did is a Google search for some requirements for a few common professions. So the job requirements for becoming a lawyer, for example. So if you want to become a lawyer, you first have to obtain a bachelor degree. You then have to complete law school. You have to pass a bar exam. You have to complete a character and fitness review. You have to swear in an oath, and you pay for a license. So this is a very rigid, very set way of requirements that you need in order to become a lawyer. It's also very costly, and it's, again, very succinct in what you have to do to pass all those things in order to become a lawyer. All right, how about becoming an electrician? Again, you have to complete a 4-year program at a vocational or a community college. You have to pass and complete a certification exam, and then you have to obtain a license. Again, very structured. You know exactly what it is you have to do. It is costly, but you know what that cost is, and very time-consuming with all the 4 years of college, having to go through an apprenticeship, and completing the exam. All right, another one here, becoming a hairstylist. Again, there's an extensive training program that you take at a community college, at a beauty school, or a cosmetology school. You have to pass an exam, you have to obtain a license, and then you have to further your career by continuing education. You have to keep going back to learning the new trends. Again, it's very structured, it's very cost-effective, and it's fairly quickly to complete this compared to being an electrician, a bricklayer, or a lawyer. So a fiber optic technician, in this particular case, it is not as structured as the other jobs that we looked at. It's really hard to define what that cost is going to be. There's no indication of how long it's going to take to complete this, and there's no easy way to determine the next steps. So again, from that Google search, if you look and say, how do I become a fiber optic technician, it suggests that you complete high school. It suggests that you have physical strength. It suggests you have color vision, because when you're working with fiber, it is color coded. They suggest you have a driver's license, and certification they have is optional. So again, where these other fields are very restrictive in what you have to be, today a fiber technician is not that structured. So because it's not structured, it's hard to really look at it and say, well, what do I have to do to become this technician? So you may think to yourself, well, let me just go to a college or university. So many colleges have a Bachelor in Science program for optical engineering. This covers the basic principles of optics. It teaches you how to apply these principles to engineering problems. It teaches you certainly communication skills and how to work in teamwork. And it teaches you how to do projects. But it doesn't really go into anything with what equipment is used, how I use that equipment. It doesn't give you the hands-on experience to really become a technician that you would get from a vocational school. It really is just the theory of how this light pulses pass down this fiber network to get data from point A to point B. So vocational schools. Many vocational schools offer fiber as part of a larger curriculum. Generally, it's associated with whatever their electrical program is. So they bring you in, they teach you how to be an electrician, they teach you how to run Cat5 cable, and they probably talk to you a little bit about fiber cable, saying this is, single mode fiber, multi-mode fiber, this is how you would install that fiber in a building. But they really don't go through a lot of how to use the equipment, how to properly terminate, how to clean, how to maintain that fiber network. So while this track is still, again, good for understanding basic theory and perhaps some of the diagrams of cable pulling, many vocational schools have little to no fiber equipment. So again, they're just talking to you about, this is what you may see. This is these are problems that you may encounter. They don't actually have the equipment there for the students to work with. So let's imagine that you've just landed a job as a fiber installer. The company issues you a fusion splicer, an OTDR, a power meter, a light source, a visual fault locator, a visual inspection probe, maybe a fiber identifier or a pond meter, a variety of tools. Basically, you'll have over $25,000 worth of equipment that A, you've never seen, and B, you really don't have any idea what to do. Just like with everything else, you certainly can go to YouTube, you can look for videos, you may be able to figure out some things on your own, but really that's not how you want to enter that job, trying to learn in that fashion. So as more and more companies started coming to us, asking us, how do you use a splicer that we purchased from you? How do I read an OTDR trace? What's a loss budget? Many technicians who found they could get a job but needed help to advance their career to become a better fiber technician, all these people started coming to us for help. Because we've been in the industry for so long, we basically knew how all these tools worked. So what we did is we decided to develop a training program that would allow for the development of a technician based upon our knowledge and our time in the field. With that, we built what we called a professional track. This track builds on the skills that's learned at each level until mastery is achieved, until the student is a professional. So how do we develop our material? All of our training courses utilize the telecommunication standards from the Telecommunication Industry Association, TIA, which is an offshoot of the Electronic Industries Alliance, the EIA. These standards address commercial building and cabling for telecommunications products and services. So by using these standards, we ensure that students that leave our class will have the knowledge that's required to install fiber anywhere in the world based upon these global standards. We've broken our training down into several levels. The first level we call the installer level. So the installer level provides students with theory so that they can understand the basic principles. This theory portion is generally provided to the students online. They have access to this material for up to a year. So once they take the class, they actually can go back and they can use this as a refresher. But it gives them the ability to go at their own pace and learn that information that they're going to need of how fiber networks are built. From there, we have an extensive 2-day hands-on lab that we go through. That the students are using the tools, they're using the equipment with an instructor that's been in the field generally for 10 plus years. So we focus on cable termination, proper cleaning, testing, and inspection, how to splice in a splice tray, and how to take basic test measurements. From this 2 days of training with this theory, it gives a technician the basic level information they would need to be a fiber to the home technician, to be able to terminate a fiber at a building or at a residence. It gives them enough information that they could get started at apprenticeship level and feel confident that the exact same things that they learned in our class are the same things that they're going to see in the field. In addition to our installer class, we've also added a number of what we call specialty classes. While fiber networks are generally very similar, there are some unique things to industry, different types of termination, different types of fiber, perhaps different types of testing equipment that's done. So whether or not you're doing fiber to FTTX, fiber to the home, fiber to the building, if you're doing fiber to the antenna, fiber to wind turbines, fiber to oil and gas, military applications, mining applications, audio visual, telecommunications, traffic systems, or utilities. We've got modules that students can come back, so regardless of which industry they are working in, they can get specific training for the types of fiber networks that they're working with on a day-to-day basis. Once you go through that level 1 and your specialty, the next thing you do is you come back for a technician level class. These technician level classes build on the principles that were learned from the installer classes and the skills that were developed once the students have been in the field. So the timeline would be is you either land the job or you are looking to get a job, so you take that installer class to get the basics down. You then go in the field and you work for 6 months to a year to get some practice built up, because when you're in class and you're doing hands-on labs, you get to do them once or twice, then you leave. It really is a repetition. The more you splice, the more you test, the more you are in an enclosure, the faster you become, and it becomes, you don't have to think about it, it becomes repetitious. So we want that to happen, and then you come back for this technician level. Then it goes into basically building on what you've learned, and we start giving you hints and tips. We start going a little bit deeper into the, well, now you're not only an installer, but after you've installed, you really need to test what you've done. And does what you've installed, did the splice, was it a good splice or did it have a problem? When I look at the network, is there too much reflection? Does it not pass? You start to look at some of those things. The next thing after becoming a technician is generally a technician will decide that I'm going to either become an inside plant technician or an outside plant technician. And that generally is going to be based upon what kind of jobs you're getting, whether or not your company is an outside plant contractor or whether your company is doing data centers and you're terminating to racks in a data center. Once you decide those tracks, then you decide, am I going to be a splicing technician or am I going to be a testing technician? There certainly are technicians that can do both, but typically we start to see as you advance people becoming more specialized in either I'm a splicing technician or I'm a testing technician. We have 3 separate modules that we offer. We have an outside plant technician course, a fiber optic technician course which deals more with inside plant and data center, and then we also have an emergency restoration course. This one specifically is for hurricanes, tornadoes, anything that would happen where the lines are down due to some sort of weather, some sort of natural event, or whatever it happens to be, landslide, where communications would be down in a region and technicians have to come in, and we're not looking for quality work at that point in time. We're looking to get communication lines back up as quickly as possible, and then after that point, during maintenance windows, going back and doing everything maybe the way it should properly be done. Once you've completed those technician level classes, the next level classes we have are called master's classes. And these really are set up to develop a strong skill set for a technician in either testing fiber optic networks or splicing fiber optic networks. Testing, you really focus a lot on trace analysis. So testing fiber from end to end, trying to determine what performance issues there are, what resolution you have, what the testing environments are. Years ago, when we weren't, we were pushing, to the desktop, maybe we were doing a gig. Fiber was more lenient. Today, we're doing 40 gig networks, we're doing 100 gig networks, and the fiber has to be tested to a more pristine level when we're pushing more and more data across that fiber. So if there's a problem, if there's too much bend in the fiber anywhere along the way and you test that out, those things have to be repaired in order to get the best, fastest networks possible. And then from splicing, obviously we're teaching advanced splicing techniques such as mid-span entries, ribbon cable splicing, and how to do proper slack management on a pole. So you want to make sure that if something does happen and there's a break, you've got enough slack that you can relax some of the fiber, have enough spare cable there to mend and to splice the fiber and get those communications back up and working as quickly as possible. So the last requirement that we mentioned for a professional technician is certification. Currently, there are 3 commonly accepted certifications in the industry. The first is the Fiber Optic Association, or FOA. FOA is an international nonprofit educational organization that is chartered to promote professionalism in fiber optics through education, certification, and standards. It was founded in 1995. The FOA is probably the oldest certification license that's out there, and today it's probably the easiest one to obtain. Their criteria for passing a technician is not nearly as stringent as that of the ETA or TFS. ETA, the Electronics Technician Association, represents the electronics industry, from technicians and educators to corporate institutions. ETA has issued over 150,000 technical certifications covering more than 80 different programs in a variety of fields. ETA is probably the most recognized certification, and it's certainly a very good certification, but their testing is all multiple choice, which we felt still leaves some area for growth or for really testing out a technician to understand the material that they've learned. And then the last certification is TFS, the Fiber School. And this is our certification through fiberoptic.com. The TFS exam is based on industry standards just like ETA and FOA. There is a multiple choice question just like the ETA and the FOA, but we've added a practical exam for our technicians. This practical exam is a series of questions that are more theory-based questions as opposed to just, can you circle the right answer? And the questions would be more like question number 1. If I'm building a fiber network from building A to building B and the distance is going to be X, which fiber would I use and why? So it really tests the student's knowledge of what information they've learned and do they have the ability to apply that knowledge and to problem solve. Many states do not require that fiber technicians have a license of any sort. So in some cases, it's just a matter of whoever the customer is may require or request that the technician be certified, but it's not always necessary. I'm sure that this is something that's going to change. Again, if we think about it, copper networks been installed for 100 years. We have those rigid guidelines that are set for becoming a professional. We were not quite there yet with fiber, so we don't have those stringent test measurements in place. But that's what we've really done here at fiberoptic.com is we are trying to set the stage for the industry, saying There do need to be standards. Technicians do have to have a certain amount of information. They do need to be certified, and we are trying to provide that and set that early stage. So in conclusion, who is a fiber optic technician? A professional technician is not defined by any governing body, but is a technician that is proven through a series of trainings and certifications that they are knowledgeable in the craft and have confidence to be able to lead in the field. How do I become this fiber technician? Well, fiberoptic.com fills this void in the marketplace by providing students with a single training organization that offers various levels of courses from apprenticeship through professional to make sure that they are properly trained and are confident in the field to be able to master any problems they may come across. And what are the requirements? So as we mentioned before, compared to many professions, becoming a fiber technician can happen fairly quickly without years of education before gaining employment. A high school diploma or equivalent is preferred by many companies, and a certification from an industry recognized testing center is generally a good thing to have to get you started. It really is an exciting time to be in the industry with all the new advancements that are happening every day. For anyone that's looking for an opportunity to enter the field and become a fiber technician, or for anyone that's in the field that's looking to advance their career, fiberoptic.com has created this real-world training that you'll need to be successful. As we've pointed out throughout this presentation, there is a current demand for skilled technicians, and with the anticipated need in wireless from cell towers to DAS and small cell, from fiber to the home and businesses for fiber to the home, telemedicine, fiber in utilities, in mining, oil and gas, military, we believe that there's going to be jobs for years to come. And compared to many professions that you may consider, you can become a fiber technician faster and more cost effective than most other career choices you may be currently looking at. Fiberoptic.com has been a global leader in fiber product sales for more than 10 years, and through our company Adtell Integration, we've also been installing, testing, and terminating fiber for over a decade. Our training program was developed by incorporating the TIA-EIA standards with real-world exercises to simulate field installations. Throw in our certification, and that's what you need to become a professional technician, and all of this coming from a single company. I hope you've enjoyed this presentation, and at this time, I invite you to type in any questions that you may have. Great, thank you. So I have my first question. The question is, are there recognized certifications that allow someone to claim themselves as a field trainer or a proctor, or is that decided by the individual company they are employed to? I know we all can't be Terry Power, but I was wondering if you offered courses like this. So the answer to that question is most of the certifying bodies that we talked about, FOA, ETA, and TFS, you have to pass a course that is the trainer course in order to be a certified instructor. Generally what you have to do is you have to prepare your own course material. So let's say that you worked for Comcast and you wanted to have your own instructor and you wanted to have your instructor certify your technicians. You would have to develop your own fiber course. You then have to submit that course to ETA, to FOA, to TFS. That course is then reviewed. From there, that trainer would then have to pass an exam through one of those certifying bodies, and then they would be able to offer a certification through either one of those organizations. So I hope that answered that question. Okay, so I don't see any other questions. I'll give it just a couple more minutes. And again, I really appreciate everybody's time this afternoon, and we look forward to hopefully, if you do have any other questions and you would like to reach out to me directly, my email address is Sonny, SONNY, .hunt @fiberoptic.com.